is all about phosphorus. Okay, phosphorus. So whenever you are going to study about phosphorus, you should remember all these things. Okay, you should remember all these things. Okay, bluish green foliage is due to the phosphorus deficiency. The reddish purple tip of leaf margins is also due to the phosphorus deficiency, right? So how to correct this phosphorus deficiency? Okay, how to correct this phosphorus deficiency? Generally, phosphorus is applied as basal application by band placement or any other thing. So phosphorus is applied as basal application by band placement. So the following are the phosphatic fertilizers like SSP, TSP and basic slag, etc. You should apply SSP, even SSP, single superphosphate or triple superphosphate, basic slag, and the most important thing is diammonium phosphate, DAP. You should apply DAP. Farmers are interested, they are very interested in applying this DAP. So diammonium phosphate, so it provides phosphorus and in some quantities of nitrogen and phosphorus fertilizers it's provide, so that farmers are very interested in using this DAP. Okay, DAP provides nitrogen and DAP provides phosphorus also, so that the plants will uptake that phosphorus. So you just remember one thing, the phosphorus. Okay, phosphorus should be applied as a basal dose. Okay, the actual recommendation is that you should apply the phosphorus as a basal dose fertilizer. What is that basal dose? What is that basal dose? Okay, you should apply the entire phosphorus fertilizer according to your recommendation. Okay, you should apply the entire phosphorus as per the recommendation, should be directly applied to the soil even before the plantation takes place. So okay, this type of application is called as basal application. Basal dose, you should apply this phosphorus content as a basal dose fertilizer. Okay, what is basal dose application? The entire phosphorus content should be applied to the soil even before the plantation takes place. Okay, plantation, even before the plantation, you should apply the entire phosphorus content. You should not split that content. Okay, basal dose completely meant for the application of phosphorus fertilizer. Why this entire phosphorus content should be applied even before the planting? So the actual reason is that the phosphorus content is completely required by the plant roots. Plant root development is more important at early stages. Okay, if the root development is proper, then the plant will establish its roots properly, and finally the establishment of the plant is very good, and then the plant establishes properly. Okay, this is the importance of phosphorus. Phosphorus required for the plant root growth. So when you apply the entire phosphorus content as a basal dose, then automatically the phosphorus content will reach the plant roots. Okay, plant roots. So actually the phosphorus cannot move in the soil. Phosphorus moves only in the plant itself. Whenever it reaches the plant, then it will move freely in the plant, but in the soil the phosphorus cannot move itself. The plant roots itself move towards the phosphorus content. Okay, phosphatic ions, the plant roots itself moves towards the phosphatic ions. That's why the plant root growth will appears. Okay, you should remember all these things. The entire phosphorus content should be applied even the plantation not takes place. Okay, that is the basic basal dose. Okay, phosphorus content, the entire phosphorus fertilizer application is required to apply as a basal dose only. But in general farmers doesn't apply this entire phosphorus content at once. So they used to apply this phosphorus content in first dose or second dose, or 15 days after plantation, or even 30 days after plantation, or just like that. So it requires, the phosphorus requirement is more at earlier stages only. Okay, at earlier stages it requires more with the phosphorus content. but this recommendation doesn't followed by the farmers, and most of the farmers use this phosphorus fertilizer, and they apply the phosphorus fertilizer even at 15 days or 30 days also, just like that. So that's why the plant roots shall not grow properly. Okay, that's why the establishment of the plant is also poor. Okay, when you apply like that, the establishment of the plant is also very poor, because the phosphorus is not mobile in soils, it mobile only in the plants. So that's why if phosphorus content is not there, so then automatically the plant establishment will be poor. But just here, actually in Andhra Pradesh and Telangana states, and Telangana states, the phosphorus content is more in soils, because farmers using the DAP and SSP contents more and more and more directly to their fields. Okay, that's why the phosphate rich soils are there in almost all Telangana and AP soils. Phosphorus content is very rich. So that's why you should go for a soil testing, and you should estimate the phosphorus content present in your soil, and then only you should apply the phosphorus. Otherwise, the phosphorus content, the nutrient phosphorus is accumulated in your soils. Okay, most of the soils are accumulated with phosphorus. Okay, because phosphorus is non-mobile in soils. Okay, phosphorus is non-mobile in soils, but it is mobile in plant itself, but it is non-mobile element in the soil. When it is present in the soil, it is a non-mobile element. It cannot move from one place to the another place. The plant root should reach the nutrient content, the potassium content, and otherwise it cannot move from one place to the another place in the soil. Some phosphorus solubilizing bacteria is there. Okay, some phosphorus solubilizing bacteria is there. That's phosphorus solubilizing bacteria solubilizes that phosphorus content, and it the solubilized phosphorus should reach the plant roots. Some bacteria and some microorganisms are there. They helps in the the movement of the phosphorus content directly to the plant roots. Okay, that is the another case. This is all about phosphorus content. I have given you a clear information or clear picture about this phosphorus and its importance. Okay, phosphorus is one of the most important things which is for the plant root growth. For plant foliage growth, nitrogen is required. For plant root growth, the phosphorus content is essential. So you should provide that essential content. Okay, you should provide that essential nutrient, that is phosphorus, directly to the soil at the time of as a basal dose. You should apply it as basal dose. Okay, not in first dose or second dose or third dose. It doesn't require much in latter doses, but it should be the recommendation should be like that. The basal dose, the entire phosphorus content should be applied to the directly to the soils. Okay, you should not apply the phosphorus content in first dose, second dose, third dose, like that. You should apply that entire content as a basal dose. So that is essential, right? The plants, the earlier the plants requires more phosphorus content than the other nutrients at earlier stages, right? Okay, how to correct this phosphorus deficiency? You should correct that phosphorus deficiency by providing phosphorus in SSP. We are not using TSP. Triple superphosphate is also there. The basic slag is also there, but for our general crops, the SSP is more required. SSP and DAP. Okay, farmers use DAP. Okay, let us move on to the another nutrient, that is potassium. This is also a primary nutrient. Okay, this is also required in larger quantities by the plant. So potassium is one of the primary nutrients. Potassium is also the primary nutrients. What are the functions of potassium? Okay, potassium, it is denoted by a letter K. Okay, potassium. So some people thought like that. So if it is called as potassium, why we are using this K? Okay, so that potassium is indicated by the letter, English letter K. Okay, K. That's why we are using that one. K indicates potassium. Potassium is a primary nutrient. It requires in larger quantities. It plays a major role in transport of water and nutrients throughout the plant in xylem. There is a two types of tissues are there, xylem and xylem tissue. Xylem tissue is there, xylem and phloem. There are two tissue vascular bundle. These two tissues are called as vascular bundles in a plant. Okay, xylem and phloem. So it plays a major role in transport of water and nutrients. Okay, transport of water and transport of nutrients. So throughout the plant in xylem. So this potassium contributes this transportation. Okay, potassium contributes this transportation, and it transports water and nutrients throughout the plant. Okay, this is the main activity. And another thing is that it improves drought tolerance. Okay, most important thing. Okay, as we are discussing about the El Nino, the dragon El Nino. Scientists are telling that we are facing the dragon El Nino in this year. Okay, because of the entire global atmospheric changes. We are going to face a situation that is El Nino. Okay, it is giant El Nino, or dragon El Nino, just like that, Godzilla El Nino. Scientists are naming this El Nino as with several names that officially no other title has been given to this El Nino. We are making this as Godzilla El Nino, Giant El Nino, right, like that. Okay, this El Nino at this El Nino conditions, drought conditions will be prevailing in almost all this in monsoon areas. Okay, almost all in India's monsoon areas, drought conditions may prevail. It means, so the rainfall pattern will be disturbed. Okay, sufficient rains would not be there. Okay, if rainfall is there, a cloud burst will appear. Okay, cloud burst means, so 100 to 200 300 millimeters of rainfall occurs in a few minutes. Okay, that is the cloud burst. This type of things will happen in this year, according to the scientists. So that is called as El Nino effect. Okay, that may be called as El Nino effect. So here, so this potassium improves drought tolerance. Okay, so it is essential for this year's cultivation that you should add potassium. Okay, you should add potassic fertilizers essentially to the plants in this year, because we are facing the El Nino situation. Okay, El Nino situation, scientists are recommending several crops. Okay, according to the scientists, they are telling that you should go for C4 plants. Okay, not C3 plants. C3 plants would be affected with this El Nino. Okay, you should go for only C4 plant crops. Okay, the list has been given. There is maize and all other millets like the jowar, maize, and all other things. They are C4 plants. Okay, C4 plants. So don't depend upon that C3 crops. Okay, according to the scientists, they are telling that don't depend upon the C3 plant crops. You should completely depend upon the C4 plant crops. Okay, so with this C4 plant crops, okay, according to their advice, you should provide that potassic fertilizer. Okay, you should compulsory add this potassic fertilizer, and it improves the drought tolerance. Okay, so this potassium fertilizer improves drought tolerance, and it enhances crop quality, and it enhances shelf life of the product, that is fruits and vegetables. Okay, it enhances shelf life of fruits and vegetables, and it reduces lodging of the crops, just like other nutrients. It reduces lodging of the crop, enhances winter hardiness, imparts disease resistance. Most important thing, so this part is given as a last word, that is disease resistance, drought tolerance. Another thing is that drought tolerance. Whenever you remember the word potassium, so the word that is disease resistance is the word. You should remember that thing. Okay, potassium is the one liner. If anybody asks you a one liner question about potassium, then you should say it like the disease resistance. Okay, potassium provides disease resistance. Okay, and the second word is drought tolerance. Okay, potassium provides drought tolerance, and it enhances crop quality also, and it enhances its shelf life also. You can store the products, fruits and vegetables for more days. Okay, it increases the shelf life of the particular things. Okay, so potassic fertilizer is most important. So what are the deficiencies in terms of potassium? So reduced crop yields. Okay, reduced crop yields without the appearance of definite symptoms. So the important thing is that potassium symptoms are not potassium doesn't exhibit its deficiency symptoms properly in plants. Okay, the phenomenon is called as hidden hunger. Most important bits. So the nutrient which shows hidden hunger, it is deficient in potassium, but it doesn't show its symptoms. That is called as hidden hunger. The most important bit is that hidden hunger, which nutrient shows hidden hunger. Okay, otherwise which nutrient is responsible, may be considered as a nutrient of hidden hunger. Okay, what is the actual meaning of hidden hunger? Hidden hunger, okay, the plant doesn't show any symptom. Okay, though the plant is deficient in potassium, the plant is actually deficient in potassium, and it is not showing the symptoms outside. Okay, if the symptoms are showing outside, then we can correct it properly. Okay, this plant is showing the symptoms, that's why we should supply this potassium immediately to the plant, just like in nitrogen and phosphorus. They exhibit the symptoms, but potassium is somewhat different nutrient. It doesn't show its symptoms, so the plant suffers potassium deficiency, but it doesn't show the symptoms outside. So this particular phenomenon is called as hidden hunger. Okay, this particular phenomenon is called as hidden hunger. Okay, this is one of the important thing. Okay, in examination point of view, they may ask you this question, that is which element or which nutrient is connected with hidden hunger. The word hidden hunger is related to which nutrient? The answer may be like this: is that is potassium. Okay, hidden hunger. You just remember this thing. Decrease in resistance to certain plant diseases automatically. If the deficiency symptoms are deficiency is there, automatically the plants are more prone to plant diseases and some pests also. So that's why you should invariably you should use this particular fertilizer, that is potassium fertilizer. You should add this potassium fertilizer, okay, in your plant doses. Okay, so how to correct this potassium deficiency? Potassic fertilizers applied as basal dose. Okay, you should apply this one in as a basal dose, but for light textured soils, split application is advocated in two splits. Okay, first dose and third dose, like that. Split application of this potassium is also recommended. Actually, this potassium fertilizer is also applied as a basal dose, just like phosphorus. Okay, in Andhra Pradesh, split application of N and K are recommended for light soils. Okay, and Andhra Pradesh, they are saying that split application of nitrogen and potassium are recommended for light soils. In light soils, you should apply nitrogen or nitrogen and potassium. Okay, in split applications. Okay, this is one of the most important thing. Actually, one important, I just want to tell you one important thing about potassium. This potassium is available in two forms. Particularly, this is the potassium fertilizer. Potassium fertilizer is available in two forms in general. That is muriate of potash, and the other thing is sulfate of potash. Okay, the potassium is available in the market in two forms. That is muriate of potash, MOP. Okay, what is the potassium content present in muriate of potash? What is the actual content present in muriate of potash? It is around 60%. It is around 59 to 60% of potassium present in muriate of potash. It is a red potash. It is in red color. Okay, the potash is in red color. Okay, so red color potash. Okay, the farmers usually call it as red potash. Okay, right. So this is advisable for almost all the crops except some crops like tobacco and potato. Just like those crops doesn't require this muriate of potash. Okay, it requires SOP, sulfate of potash. The other form of the fertilizer which is available in the market is SOP, sulfate of potash. So the sulfate of potash is the main requirement for tobacco and potato crops. Okay, particularly tobacco crop, MOP is not recommended. Not at all recommended. MOP is not at all recommended in tobacco crop. If you use tobacco MOP in tobacco, so the quality of the leaf will be completely deteriorated, and the quality of the leaf is completely less due to that quality. It may be the price of the product will be completely decreased. The price of that tobacco leaf is completely decreased. So because of this MOP, so that the entire tobacco farmers usually use this SOP, that is sulfate of potash. They use sulfate of potash. I'm going to ask you one simple question, that what is the potassium content? What is the potassium content present in? What is the potassium content present in? What is the potassium content present in sulfate of potash? What is the potassium content present in sulfate of potash? Okay, sulfate of potash. So it is around 50%. It is around 50% of sulfate, 50% of potassium present in SOP. Okay, the main difference between SOP and MOP is its price. Okay, is its price is more for SOP. Sulfate of potash costs around 3,000 to 4,000 rupees. Okay, nowadays the sulfate of potash costs around 3,000 to 4,000 rupees for 50 kgs bag, whereas this muriate of potash costs about 1,500. I don't know the actual price. 1,500 to around 1,500. Okay, 1,000 to 1,500, I think. So the cost of the MOP, you should know the cost of that MOP. MOP is cheaper than SOP. MOP is cheaper than SOP. Okay, for most of the crops, for 90% of the crops requires MOP fertilizer, but crops like tobacco and crops like potato, they require only sulfate of potash. Okay, they require only sulfate of potash. Okay, so this is all about this potassium fertilizers or potassium nutrient. Okay, already we have discussed about nitrogen and phosphorus and potassium. Nitrogen, phosphorus and potassium, already we have discussed about all these things. So these three are considered as primary nutrients. Okay, primary nutrients. Now we are going to discuss about secondary nutrients. Okay, secondary nutrients. Okay, primary nutrients already we just completed, and now we are discussing about the secondary nutrients. Thus in secondary nutrients, the important nutrient is calcium. Okay, the important nutrient is calcium. There are several functions of calcium is there, essential for the formation of cell wall. Calcium pectates, like those things, they are constants of that cell wall formation. Okay, cell wall formation, calcium pectate in the middle lamella of cell wall, which regulates the entry of only those nutrients which are not toxic to the plants. It's a natural mechanism to prevent toxic materials to enter into the cell. Okay, it is a natural mechanism. It doesn't allow the toxic materials directly to the cell. Okay, so this is the natural mechanism. There's a calcium pectate in the middle lamella. Okay, calcium pectate present in the middle lamella of the cell wall. So it regulates the toxic contents. So it allows only the non-toxic materials to enter into the cell. Okay, it prevents the toxic materials. It prevents the toxic material to enter into the cell wall. Okay, enter into the cell like that. This is one of the important thing. Calcium in seeds, calcium is present as calcium phytate, most important bit. Okay, you may get bits like this. Okay, you may get bits like this. Calcium is present as calcium phytate. Calcium, okay, the question may be like this. Okay, the question may be like this. In seeds, calcium is present as dash. In seeds, the calcium is present as dash. The answer is calcium phytate. Okay, the answer may be like this. The answer is calcium phytate. Option A, calcium phytate. Option B, calcium pectate. Option C, calcium something. And option D, calcium something something. Like that, like this. So they may give you the options. Okay, the answer is calcium phytate. Calcium phytate is the answer. In seeds, calcium is present as calcium phytate in the form of calcium phytate, important bit. So in root tips, okay, in root tips, calcium is very essential for the meristematic activity. Okay, the cell division activity, it will takes place in the meristematic tissue, and it is essential at root tips. So some bacteria and fungus are present at the soil solution, and the root cap or root tip is very important. So this calcium is present, and in root tips, calcium provides the meristematic activity. Okay, calcium is essential for this meristematic activity, that is cell division. Okay, it is essential for cell division. Other thing is that it provides base for neutralization of organic acids. Okay, neutralization of organic acids will take place. Neutralization of organic acids, which affects the neutralization of organic acids and other toxins in plants. The answer is calcium. Calcium neutralizes the organic acids and other toxins present in the plant or produced in the plant, right? So the things are like that. The questions may be like that. So which nutrient is essential for the neutralization of organic acids and toxins in plants? That is calcium. Okay, so which nutrient is present at root tips? And helps in meristematic activity. That the answer is calcium. Okay, in seeds, calcium is present in the form of dash. The answer is calcium phytate. In cell walls, the calcium is present in the form of dash. The answer is calcium pectate. Right, just like that. These questions may be the questions may be like that, so that you just remember. This is also one of the important thing. Calcium, you may get some important questions from this calcium. Okay, calcium. Another thing is that favors assimilation of nitrogen into organic constituents, especially proteins. So assimilation of nitrogen, assimilation of nitrogen contents. Okay. All right, the deficiency symptoms. Deficiency of calcium. Deficiency of calcium. Let us see the deficiency symptoms of calcium. So this is one of the important bits. I think some in one or two previous papers. I think I have seen this question in previous papers. So what is that question? In apple, the discoloration of the fruit meat. In apple, the discoloration of the fruit meat, the condition generally referred to as bitter pit in apple. Okay, so the nutrient which is responsible for the bitter pit in apple is calcium. Bitter pit. What is bitter pit? How that deficiency symptoms will appear in apple? Discoloration of the fruit meat. Discoloration, completely discoloration occurs. This condition is called as bitter pit. Apple in apple crop. So this condition will appear, that is bitter pit in apple. Right. So another thing is that blossom end rot in tomato. One of the most important bits, calcium deficiency. Due to calcium deficiency, blossom end rot in tomato, that blossom end rot will appear. Okay, most important bits. These two are important bits. So in examination, this type of questions will appear in examinations. Blossom end rot in tomato is due to calcium deficiency. Important thing, you should remember, it is an important thing. Blossom end rot in tomato is due to the calcium deficiency. Important bit. Blossom end rot in tomato, and bitter pit in apple is also the also due to the deficiency of bitter pit in apple is also due to the deficiency of calcium. How to correct this calcium deficiency, because it is a secondary nutrient. Okay, how to correct it? What are the corrective measures? That calcium as a plant nutrient is more important in calcium deficient acid soils. Okay, plant nutrient more important in calcium deficient acid soils. The application of carbonate or sulfate salts of calcium, carbonates gan, or sulfate salts of calcium 2 to 4 quintals per hectare in furrows could increase the yield by 48%. Okay, actually the what you should add, they have not given the actual control of calcium, but they are telling the application of carbonates. Okay, application of carbonates or sulfate salts of calcium means calcium carbonate and calcium sulfates. Okay, you should add calcium carbonates and calcium sulfates at 2 to 4 quintals per hectare. Calcium carbonate, calcium sulfate means that is gypsum. Okay, you should add this calcium carbonate and calcium sulfate things or directly to the soil at a quantity of 2 to 4 quintals per hectare in furrows could increase the yield by 48%. Okay, okay. But how many people are there? Okay, wow, great. So many people are there. Sirisha garu, Ramalakshmi garu, Chari garu, Madhavi garu, and Lakshmi garu. Wow, great. How many people are there? I think this class is very interesting. Okay, thank you, thank you very much for attending this class. Right. Right. Another important nutrient is that magnesium. Okay, another important nutrient is that magnesium. Already we just discussed about magnesium. Nitrogen, phosphorus, potassium, and magnesium is also mobile, highly mobile in plant tissues. Okay, the nutrient will move from one place to another place in the plant tissues. Okay, it is the highly mobile, it shows high mobility. Okay, this magnesium shows high mobility in the plants. So what are the functions of magnesium? Okay, let us see the functions of magnesium. The usual concentration of Mg plus 2. Okay, this is ionic form. Mg plus 2 in crops varies between 0.1 and 0.4%. So this is an important bit. Okay, just like in nitrogen, less than 1% shows that the plant may be considered as nitrogen deficient plant. Just like that, so magnesium deficient plants shows these symptoms. Okay, usual concentration of magnesium in crops varies between 0.1 and 0.4%. Okay, okay, usual concentration is like this, 0.1 to 0.4%. A large part of magnesium is associated with organic anions like malate. Okay, large part of magnesium is associated with organic anions like malates. Right. Magnesium is the only mineral constituent of chlorophyll. Most important thing, you just highlight this one. Magnesium is the only mineral constituent of chlorophyll located at its center. Okay, it is at the center of chlorophyll. Okay, our chlorophyll content is there. Chlorophyll is directly related to magnesium. The central atom is magnesium, so that it is the only mineral constituent of chlorophyll is what? It is magnesium. Magnesium is only the mineral constant of chlorophyll. Important bit. Chlorophyll formation usually account for 15 to 20% of total magnesium content of plants as magnesium porphyrin. Okay, chlorophyll formation ke నీకు ఖచ్చితంగా ఇదైతే కావాలన్నమాట. So chlorophyll formation usually accounts for about 15 to 20% of total magnesium. Okay, if we apply 100 kgs of magnesium, In that 100 kgs, 15 to 20% of the magnesium should be used for the formation of chlorophyll. Okay, that is the actual meaning of 15 to 20%. We should not use 100 kgs magnesium. For example, I am telling you that you can easily understand that if you apply 100 kgs of magnesium to the soils, then in that 100 kgs, 15 to 20% of the total magnesium is utilized for the formation of chlorophyll. That's all. So in the form, in which form it will take? Okay, the answer is magnesium porphyrin. Okay, it takes the magnesium in the form of magnesium porphyrin. So the entire magnesium content, the in that entire content, 15 to 20% of the magnesium content is utilized for the formation of chlorophyll in the form of. So it takes the chlorophyll in the form of magnesium porphyrin. Okay, magnesium porphyrin, just like that. So serves as a structural component of ribosomes. It is also a structural component of ribosomes. And seeds contains magnesium as salt of phytic acids. Okay, already we just come across a bit in calcium. So calcium is present in calcium phytate, and somewhere we just come across this particular bit. I think it is in potassium. Some phytate. Okay, already we just discussed about that phytates in seeds. Okay, calcium in seeds, calcium is present as calcium phytate, like that. Just magnesium, that seeds contain magnesium as a salt of phytic acids. Okay, phytic acids, right? What are the deficiencies in terms of magnesium? Mg plus 2, ionic form is Mg plus 2. Okay, you should remember that ionic forms in this material, they have not given the ionic forms of several nutrients, but it is very important that you should get that list, a list of anion forms. Some are cations, some are cations. Anions and cations are there. So what are the anion form and what are the cationic forms? So you should get that list. Otherwise, I will provide you that list. So here this is magnesium. The ionic form is Mg plus 2. Is a mobile element. Okay, it is highly mobile in the plant and is readily translocated from older to younger plant parts. Okay, just like nitrogen, just like phosphorus, and this magnesium is also moves from one place to the another place, from older tissues to the younger tissues in the plant. Okay, it is also moves from one place to the another place, younger tissues to the older tissues to the younger tissues, younger leaves, just like that. In the event of deficiency, okay, if deficiency occurs, the older leaves directly send that magnesium ions to the younger leaves. Okay, younger parts or younger leaves, just like nitrogen and phosphorus. So the magnesium deficiency. Okay, the magnesium deficient plants usually have less than 0.1% of magnesium. Important thing. Okay, if the magnesium content present in the plant is less than 0.1%, then the plant considered as deficient in magnesium. It is less than 0.1%. Less than 0.1%. You just write like that. Okay, if the magnesium deficiency is less than 1%, 0.1%, then the plant is considered as a deficient plant for magnesium. Okay, you should supply some magnesium. Then some important things are given here. So magnesium deficiency. Okay, related to magnesium deficiency, magnesium deficiency is common in the plants grown on coarse textured acidic soils. Okay, this is also an important bit. So magnesium deficiency is common in dash soils. That is, answer is coarse textured acidic soils. Two conditions. Okay, they are coarse textured soils, means sandy soils are just like that, sandy loams or like that. coarse textured soils and acidic soils, prominently acidic soils. In acidic soils, this symptom, deficiency symptom will occur. Okay, the magnesium deficiency is common in the plants grown on coarse textured acidic soils. Coarse textured acidic soils, important bit. So in some vegetables, intervenal chlorosis with the tints of red and orange and purple colors. Three colors has been given here. So what are those three colors? Red color, orange color, and another thing is purple color. Okay, ROP, red, orange and purple colors is observed. Okay, intervenal chlorosis. Intervenal chlorosis. So chlorosis throughout the veins. Okay, veins, throughout the veins, chlorosis. Chlorosis means discoloration. Chlorosis means discoloration. Loss of that green color is called as chlorosis. Okay, every leaf is having that green color. Okay, intervenal chlorosis means throughout the veins, the leaf loses its green color. Okay, other than green color or yellow color will appear on the leaf throughout the veins. Okay, throughout that veins and venation, right, like that. So in some vegetables, intervenal chlorosis with tints of red, orange and purple colors is observed. Grassy tetany, you just remember this thing, grass tetany. What is grass tetany? Okay, what is grass tetany? Cattle consuming forages with low magnesium, may suffer from hypomagnesemia. Okay, just try to understand that situation. A plant is there. Okay, a plant is there. This is the plant. Okay, this plant is deficient in magnesium. Okay, this plant is deficient in magnesium. A cattle is there. Okay, this cattle comes to this plant and it eats this plant, this magnesium deficient plant. Okay, the cattle comes to the magnesium deficient plant and eats that magnesium deficient plant. Okay, it consumes the plant. So what is then grass tetany? It is cattle consuming forages with low magnesium content. They suffer hypomagnesemia, means low level of blood magnesium. Low level of blood magnesium because of the the lack of magnesium content in the plants. The cattle suffers this disease that is called as hypomagnesemia. Hypomagnesemia, right? Hypomagnesemia, which means low level of blood magnesium. So the cattle suffers with this disease because due to lack of magnesium in the forage crops. So it leads to a disease. What is the disease? Hypomagnesemia is the disease. Low level of blood magnesium, that is called as hypomagnesemia, and it is also commonly known as grass tetany. Okay, and it is also commonly known as grass tetany. Okay, cattle consuming forages which are low in magnesium content. So that cattle suffers a disease. The disease is called as hypomagnesemia. Okay, so hypomagnesemia, the disease is called as. And what is hypomagnesemia? Hypo. Okay, hyper means more content, hypo means less content. You just understand like that. Hypo means less content. What is less here? Magnesium is less here. So that's why it is termed as hypomagnesemia. Low level of blood magnesium. Okay, low level of blood magnesium, and it is also commonly called as grass tetany. Okay, grass tetany. Okay, here also something is given here, grass tetany. Cattle consuming forages with low magnesium may suffer from hypomagnesemia, that is low level of blood magnesium, commonly known as grass tetany. The same lines has been given again here. So this happens due to the high levels of, this is important. This one is very important. Why this happens? Why this magnesium content is low in that forage crops? So why the magnesium content is low? So the reason behind the low magnesium content in the plant is that it is due to the high levels of ammonium. Okay, high levels of ammonium and potassium application. So if we apply high levels of nitrogen, okay, high levels of nitrogen in the form of ammonical fertilizers and potassium application, this leads to the this leads to the deficiency of magnesium. If you apply nitrogen in more contents than the recommended doses, and if you apply potassium is more than the recommended doses, then it results in the deficiency of this magnesium contents. Okay, you may ask you, so what is the relation between this nitrogen, potassium and magnesium? Okay, some interactions will be there. Okay, some interactions will be there among the nutrients. Nitrogen, potassium contents, if apply in larger quantities, it leads to the magnesium deficiencies. Okay, it leads to the magnesium deficiencies. I have just told you that about basal doses. Okay, basal doses, we are going to apply phosphatic fertilizers. Okay, in some cases there is a recommendation for zinc also. Okay, in some cases zinc also recommended. You should not apply both phosphorus and zinc at a time. You should not mix those fertilizers. Okay, a considerable period should be there in applying this phosphorus fertilizer and this zinc fertilizer. Okay, zinc also directly apply to the soil, and phosphorus fertilizer is also directly applied to the soil as a basal dose. You should not mix these phosphorus and zinc at once. Okay, you should apply phosphorus before or zinc before. After some days you should apply the other fertilizer. You should not mix those fertilizers. So some interactions will be there between the nutrients, phosphorus and zinc. The interactions will be there. Okay, if we apply both the fertilizers at the same time, so because of that interactions the plants will suffer. Just like that, here the if you apply nitrogen and if you apply potassium in higher quantities, it leads to the deficiency of magnesium. If the cattle eats that magnesium deficient plants or forages, then it leads to the disease. What is the disease? The disease is called as hypomagnesemia. Hyper means higher, hypo means lower. The lower magnesium content disease, that is hypomagnesemia, and it is also commonly known as gross tetany. Most important bit, gross tetany. Okay, gross tetany. This is also one of the important diseases. Okay, in cattle which is consuming forages with low magnesium content, they may suffer from hypomagnesemia. That is, hypomagnesemia means low level of magnesium content, that is blood magnesium content. Okay, why this condition happened in that forage crops? You just applied more nitrogen than the recommended doses. You just applied potassium than the recommended dose. So that's why, so this higher application of this nitrogen and potassium, particularly the nitrogen in the form of ammonical form, ammonical nitrogen. Here they have given ammonical form, NH4 plus is the ammonical form. NH4 plus is the ammonical form of nitrogen application. Okay, nitrogen, the nitrogen fertilizer is available in different ionic forms. You should know the ionic forms. This is ammonical form. So this is NO2 minus is nitrite form, and another form is that NO3 minus. NO3 minus is nitrate form. This is the most favorite form by the plants. Plants absorb this type of nutrients more. So in these three types, the nitrogen is available to the plants. This ammonical form is more dangerous, and this ammonical form leads to the magnesium deficiency. You just remember that one. Okay, this leads to the magnesium deficiency, right? Okay, some other nutrients are also there. Sulfur is there, sulfur, zinc, and copper, iron, manganese. Some 5 to 6 nutrients are there. So but today it is not possible to cover all those things. Tomorrow let us cover all those things. The interested candidates should come to they are advised to come to these classes. So I'm not insisting you to attend my classes, but it is your choice to appear for these classes. The most interesting thing, so somewhat interesting subject. We are discussing some interesting subject. Some another 5 to 6 nutrients or elements are there. So this is one of the important things in the examination point of view also. Okay, with this the second part has been completed in 121 material. We just divided that 121 material into 3 parts. So the first part is already over, the soil physical properties and all other things. The second part is now over. So with this soil nutrients, that is plant nutrients and other things, the five I will discuss all those things, the five nutrients, and the second part is completed. In the third part, some important things are there, that is problematic soils. That is also one of the important things. Okay, and the problematic soils are also one of the important aspects, and we are continuously getting some important bits from that particular areas, how to correct those soils. Okay, so several um, several things are there. How to correct the problematic soils. Okay, how to correct those problematic soils, and all other things are there. Some several tables are there. Several important things are there. Somebody has sent some message, that's why I just stopped here. M Lakshmaya. Oh, Lakshmaya. Yeah. All right. Okay, friends, let us discuss all these things tomorrow. Okay, interested candidates, please attend my classes. And thank you very much, Ravteja Garu. Take live classes of entomology. Already a lot of 131 classes are covered in live classes, Andy. Okay. How many people are there? How many interested people are there? Wow, Sari Garu. I'm fine, Andy. How are you? And what you are doing now? You are, I think you are my old student. Hi, Sirisha Garu and Madhuri Garu and other things. Okay, thank you very much for attending this class. And tomorrow also we are going to discuss these things and other things. I will give you the link of an examination today. Yeah, Zoy, అమలాపూర్లో ఉన్నాడంటే రాలేదు ఈ వారం. He will come in the next week. Okay, I think he will come by the Saturday or Friday, like that. ఉన్నాడండి, కాల్ చేస్తున్నాడు. ఓకే, హౌ ఈజ్ టుడేస్ క్లాస్? Just drop a comment or send your reactions. How is our today's class? Have you find any difference? Okay, I think today's class is somewhat better. Okay, change a little bit change in our daily classes. Today's class is somewhat different class when compared with all other classes. Okay, I think you can easily understand my language. I am using a simple and simple language. Simple language. I think you can easily understand all these things, right? Okay, friends, thank you very much. Bye, good night, and let us meet tomorrow. And thank you very much. All right, thank you very much. Bye. Wow. Okay, friends, bye, good night. Let us stop here, and I will take another class tomorrow. Thank you very much. Bye, Sirisha Garu. Bye, Madhuri Garu. Bye, Lakshmaya Garu. All other people. Thank you very much. Bye, good night.